Greetings and welcome to another installment of QuantSlob. This is third in our basic application series. This time around, part 2 in our mini-series on probability sampling distributions. We're going to pick up with our trusty deck of 52 cards. Let's imagine a theoretical random sample of 2 cards from our standard deck of playing cards. For this example, we're going to say that the 2 cards must be unique. Our theoretical random sample cannot contain the same card twice. I want to point out that our foundational series provides us with a very flexible toolkit. We have an alternate but entirely equivalent way of imagining this theoretical random sample of size 2. We simply imagine a population that contains every possible ordered pair of cards. So for example, this population contains the element Queen of Spades, then the Jack of Diamonds. If you play Pinochle, you might appreciate this element. It also contains, for example, the 10 of Diamonds, then the Ace of Clubs here. It also contains, for example, the Jack of Diamonds, then the Queen of Spades here. It just so happens that this population contains 2,652 elements. And by the way, to tie together what we've learned here, this population, the way we're thinking about it, is essentially imaginary. But there's nothing stopping us that we could create, if we wanted to, a population, this population as a concrete population, like if we worked in a card factory and had access to lots of decks of playing cards and a lot of free time. I don't know why we would do such a thing, but we certainly could. So moving forward, here is our probability sampling distribution of sample proportion of clubs in a theoretical sample of size 2. Notice the vertical line on the plot, which marks a value of 1/4. This is the population proportion of clubs. And I want to restate something that was emphasized in the series kickoff. Right now, we're not concerned with how these sampling distributions are calculated. There's plenty of time for that later. Right now is big money time. We're looking for patterns, the really important things here, particularly how the shape and width of the sampling distribution change as the sample size increases. Probability sampling distribution of a sample proportion of clubs in a theoretical sample of size 3. What about sample sizes 4, 5? And so we have an animation here. We're increasing our sample size. So what do we see here? Well, for one thing, the distribution seems to be centered at 1/4, the vertical line, the population proportion. The distribution seems to have a sort of bell shape here happening, and the distribution gets narrower and narrower as the sample size increases. And in this particular case, once we've sampled the entire population, we've sampled all 52 cards, what is the probability? The ratio of clubs will be 1/4 in our theoretical sample of the entire population. It must be 1/4, probability 1. When we sample the entire population, the random variable sample proportion equals the population proportion with probability 1. And we're going to pick this up in part 3, and that's going to do it this time around. Thank you so very much for tuning in, and don't forget to stay tuned for more QuantSlob.